right, thanks everybody. I'll start off by introducing myself. Pretty exciting day here. My name's Glenn Hurwitz. I'm a mechanical engineering manager at Andrews Cooper, which is an engineering consulting firm based in the Seattle, Oregon area, Seattle, Oregon. And I primarily focus in hardware and medical device testing, particularly on the mechanical side. I can already hear microphone feedback, so sorry about that. Yeah, and I'll pass it off and everybody can introduce themselves, and then we have a couple questions for you. Colton, you want to start us off?
Yeah, I'm Colton Black, and I'm the CEO of an early startup, Onyx Systems. Previously, I was at Recon Tools and at Formlabs. I've done a mix of electrical systems, mechanical, and software engineering, so I've done a lot in the manufacturing hardware space.
Hi, my name is El, and currently I'm at a company called Latitude AI, where I'm leading the kind of software test infrastructure for advanced like ADAS type solutions for Latitude. And previously I was at ChargePoint leading kind of their global test operations as the director of test engineering. And I must be speaking about my experience back at ChargePoint, but a lot of the same things, the more advanced stuff I'm getting to do at Latitude now. So,
hello, I'm Shri. My full name is Srinivas Melicheru, and I've formerly at Meta as a director of test engineering, manufacturing infrastructure, data, AI systems. And my career has been pretty much in consumer electronics, working at Apple, Google, and Meta, doing operations and supply chain and business enablement systems.
Hi, I'm Pete Staples. I'm CEO and co-founder of Blue Clover Devices, and I'm a strong advocate for testing as we make a product called the PLT for a production line tool, which is used to streamline in-circuit and functional testing. And I and my fellow panelists hope to assert that test is really the difference between going to Hawaii and celebrating a product launch successfully or going to deposition for criminal negligence for a product failure. No one designs a car to kill people. It's not your intent that matters, it's what you test that decides where you go.
Well, Pete really cut straight to the point, so I think we might be able to save 30 minutes. Test is important, and you should talk to us early and often. But other than that, maybe, Colton, do you want to start us off on what you see as the most significant challenge facing the test world right now?
Yeah, so I think we spent a lot of time today talking about the next wave in manufacturing, and but I do think though there is a lot of room for there's still a lot of really old school the firms out there that are designing products and are pretty good at it, but are struggling when it comes to scalability. And a lot of that comes from just using very legacy, workflows and systems. And I think there's a lot of opportunity to kind of, bring people up and have them use, things like the cloud and the internet and databases, and not just, store data locally. So I think that's something I'm doing a lot now is, and experiencing that a lot of people are still really behind and haven't even been brought up to, the new way of doing things, not much less the future way of doing things. So, yeah.
Same question?
Yeah, go for it. Same question.
So in my opinion, I think one of the biggest challenges, at least from the test teams that I've led in the past, has to do with the fact that we're never quite given enough input upstream about like what we're supposed to test. And so a lot of companies would take these to two extremes. One is essentially slow down to write all the requirements, and the other extreme is just to just test whatever, and then last minute we'll add more coverage while we're at the factory. Both create different types of stress, and I think the biggest challenge for me as a leader is really just finding that happy medium where we do the right amount of work up front to essentially plan our coverage, but still being nimble and moving fast and reacting to what we actually see on the floor. So it's really all just that flexibility where you don't get stuck in one of the two extremes. That's my answer.
To me, it's a twofold answer. The first part is test is by far still an afterthought. Test engineering teams don't get engaged early on in the product development cycle. They get brought on later in the stages of the builds, as well as they are not given enough time to execute, pretty much, right? It's an extremely complex technical function that involves firmware, electrical, and mechanical, and robotics and mechatronic systems that have to all commingle together to deliver the final product, and we always crunch of time to deliver. The second part is, if you look at a traditional manufacturing line, it's still by far a bunch of serialized tests that test for different functions in the product. There is, when we talk about new wave of manufacturing, new wave of testing, there is a huge potential to take the reactive systems we have today and come up with a lot more predictive models, including AI and data and business systems, to really predict what the failure modes would be on a product while they're at a very early design stage. So as a pioneer in the industry, I want to look at us move from a reactive to more of a prognostic and a predictive model as we do test architecture and implementation in manufacturing lines.
Yeah, it's a tricky position to be in, to be at the end of the project, literally the end of the line in many cases. And it's like an apex predator. You get all the toxins in the ecosystem. So we're like 5 eagles up here feeling the mistakes that were upstream. And usually a product begins with its requirements. And I think it's not fun to do that part of the job, but that's where I think test engineers deserve to be invited. And like a stunning example of this was on the cover of Aviation Week, where they showed the Raptor engine from SpaceX, the first one, the 100th one, and then the 300, like a recent one. And it just went from this giant spiraling nest of hoses and cables to something a lot more streamlined. And then finally it looked like a Dyson vacuum cleaner. It was just like a beautiful black, highly simplified thing. And in the article they explain, well, we just go through the algorithm, and that is first challenge the requirements. Like really don't be afraid to push back on those requirements and be sure that the wider team is involved, including tests, because ultimately tests is going to have to prove those requirements were met. And then it was essentially simplify, and then automate. But there's this temptation, and I'm a huge believer in automation, but to just jump to, well, how do we make this production line more and more automated without taking that time to really make sure the requirements are the right ones. I think that's a key thing.
So Pete, what you're saying, Pete, right?
So I'm saying that tests should be involved in the requirements, and we should spend the time on the requirement.
I was going to say, Pete, so that means you get requirements.
Yes, assuming they exist. So that, I suppose, is a necessary ingredient.
Yeah, good points. Definitely getting requirements, having requirements, and hearing about the requirements are all important steps. I am curious, we've been talking a lot today about AI, as everybody is all the time right now. How are you guys thinking about using AI, or maybe are currently using AI? And in particular, if you're using it as a way to communicate with other teams who maybe don't have the same knowledge level or knowledge base as you. Srini, you want to go?
Sure. We've done this at Meta, right? So one of the clear applications of using AI are what we call vision language models that are using AOI systems and machine learning models to detect failures on the line and use that as a data repository for informing product development teams, right? Expediting failure analysis, expediting supply chain decisions as far as the inventory that's currently stuck in the various distribution chains as far as what the dispositions for those units are. So we've been very successful at Meta trying to do some of these tools and commingling them together into informing various positions as a whole. Besides, we are evolving into more of a business systems. Most of our implementations have been on the manufacturing side, finished goods, product development, failure analysis, but now we're expanding that more into the supply chain side to figure out the entire supply chain for the future, as well as to expedite some of the company decisions for field quality issues as a whole.
Great, thank you. Colton, did you have something you wanted to say? You were raising your mic.
Yeah, I mean, I've been playing around with different ways of using AI, and I guess one of the things that's been interesting recently is there are various methods, machine learning, AI, deterministic algorithms, whatever. But for clumping together similar tests is really interesting, where you may have a certain discrete number of failure modes in your tests. And having the ability to have a platform that can clump together different ways that those failure modes are exhibited can basically, capture, can help you capture failures that you're not correctly, targeting essentially, and can kind of help detect anomalies before they start becoming really bad. Like basically during the MPI process, when you have very limited data, basically I think there's a lot you can do with that limited data set with AI to try to piece together, like a taxonomy of sorts. I think that's an interesting path.
So I can add to that a little bit. An area that I was quite interested in previously, and I'm going to lean into a little bit more in the future, is the idea of using kind of modern generative AI tools to help essentially generate requirements. As you can tell, like I'm really all about like, sometimes I'm given a project, go test it, make sure you can manufacture it, but like nobody's telling us requirements. And so, as long as you can describe how your system works, I mean, I think systems engineering will be revolutionized by kind of AI. And you can, from there, use its system decomposition with obviously some skilled human knowledge to turn those into kind of very actionable kind of descriptions of failure modes, which then you could even ask those tools to generate like test cases. And then maybe you even go more advanced and you give it your like coding framework, and it'll actually generate some boilerplate code for your developers to work on. So I think in the past I've played around with that. The general idea is you take the understanding of the design, translate it into a human readable description of what the test should do in terms of your test framework. And at that point in time, it's very easy to offload that to like, software developers, even offshore that, like you put it into the machine and then the code comes out. I mean, I'm sure a lot of you are looking into this kind of thing. So I think AI will basically streamline all of that stuff at the beginning up to the point where you review the test cases, then you pass it to like a developer to finish the job. I think that would be pretty cool.
Yeah, we've successfully, I didn't think it would work, but we have relatively a new doc site for our test tool, and the tests are in YAML, and I just asked an AI tool I said, write a test plan, here's the documentation, I want to test this, and this, and it did magically figure it out, like it gave a usable test, so that was encouraging, and I think we would see more of that. And as for the insights gleaned, that's it seems like there's a lot of potential there. We haven't tapped that resource yet, I would say. One, Colton made the point that a lot of factories aren't even really connected. Like the test data isn't even accessible. And some people, I was at a trade show last week in Austin and people were really defending, like, we're air capped. We are locked down. Like, nobody's getting that data. I would be curious to see hands if you would agree that, like, a factory should not be, like, fully connected.
Yeah,
Not
I guess,
too
or
many.
another way of saying that, would you trust a third party with your data?
Yeah.
You know, it's a.
I guess this is an audience that tends to believe in,
Yeah,
you know,
if you're at this conference, you're probably.
you're taking pictures of product all the time and looking at it. But yeah, that just seems like you certainly want to control access, but completely cutting off the factory is not the way to secure your information.
I think you have to consider what industry you're talking about, right? I mean, defense industry versus consumer, very different requirements.
It's true.
Yeah.
Yeah.
Yeah, it is difficult when we talk about moving into the future, adapting and adopting a lot of these technologies only works if you allow it. So if you're fully locked down, there's a huge time cost in that increased difficulty of communication that I think will be an interesting conversation for a lot of people moving forward. As we are progressing and we're talking about the future of functional testing, if we were going to have this conversation in 5 years, what do you think would be kind of the next big thing that we would have been talking about? It feels like everything was AI today and recently, but I'm curious if you took a guess. I didn't anticipate the amount of imaging and image as a measurementation device that we have in testing now a few years ago. I'm curious what your thoughts are for the next thing.
I'll tell you what I hope it is. I hope that the circle, the product cycle completes and that returns, RMA processing, repair, and all that is benefiting from all the data that we collect. And I don't see that. I just see green shoots of that now. But that's a big opportunity to just make all these devices a lot better and, over their lifetimes.
I'm optimistic that the future is data rich, right? Obviously, once we get to a point where we have requirements, we have deployed a series of tests for product lines, the future has to be where all of these systems come together, whether that be data, whether that be cloud solutions, the individual test results on a given product category, all of that. As we move into the future, I'm positive that we'll be able to leverage the data we have collected over the different products that is made, as well as the different sets of supply chain. Right? It's just not functional tests. There are tests all across the supply chain, both in the forward logistic as well as the reverse logistics and service operations, where there's a lot of data that's being collected. Once we get to the future of cloud and database solutions, we'll be able to leverage the information learned to better predict what our failures are going to be throughout product development as well as the manufacturing life cycle.
So I'm going to go out on a limb and maybe play devil's advocate here in the sense that, like, I think in 5 years' time, and I really resonated with an earlier speaker, I think it was Matt, who said, you know, doing what we do, there's like, it's a craft, right? Craftsmanship. I think 5 years down the line, people are going to be asking the question of, like, what happened to all the craftsmanship? I mean, the AI is great at doing what it's good at, but you're going to find some corner case where it's unable to do it, and the company is going to be tearing its hair out asking, where are all the people who can solve this problem? Get me more AI. But since it never had enough data to train on, can't solve it. And then all that intuition, I mean, I don't know where I'm going to be in 5 years, but I feel like that's going to be a problem, but that's only because, yeah.
So if we have this talk in 5 years, you're going to be saying we should reincorporate humans.
I'm not saying that, but I want to make sure I still have a job.
Yeah, fair enough.
Yeah, I agree. I mean, it's easy to say that one day you could just, give your product over to some kind of universal test fixture, and then it just pokes at it and then establishes requirements, builds the test state, themselves, and then it just kind of figures it out on its own. But yeah, I agree. Like that, the current LLMs, the way they work is they're requiring data to actually exist. And I guess maybe you could generate synthetic data off of, I don't know. I don't see that happening anytime soon, but I do think large portions obviously will be taken by AI and made better, but that'll only augment humans, not replace humans in the process.
Yeah, I definitely think based on the buy-in I currently see from companies adopting new technologies in test, I'm not super worried about my job anytime soon. But yeah. Okay, so we've talked about some of the gloom and doom and the future. What are you most excited about right now in test?
Automation and test. I've seen over the last 10 years, test become more automated, more robotic systems implemented on the line. And I'm seeing a path where we would have, I'm not talking about the generalized testers. There is still a big application for the general bread and butter testers, functional testers for the products. But I'm optimistic that in the future we'll be able to use the automation and robotics to create more precise, more repeatable, more accurate test systems, both for product development, both for system validation, product development, and PI, as well as for manufacturing.
It's gotten so much cheaper. I'm so happy with somebody mentioned 3D printing has come a long way. So we do bed of nails fixtures, and we found a shop that could turn out these fixtures in 4 days. And that's just not been possible on a repeatable basis. You can do anything, once, but like that's a business model for them. And we have the luxury of seeing how much people spend on test equipment and how many tests are run. And the cost per test is a metric we just keep trying to drive down. And it's $1.14 right now. And so I'm just excited about getting that under $1. And our space is defined by these $1 million machines and $50,000 bed of nails, things that fit in them. So it's exciting to just see that completely change.
So it's really quick. I mean, one thing I'm excited about is the fact that because there's a big push to move everything faster, my scope as someone kind of working in tests actually has bled into validation simply because, companies want to save money. They don't want to build that many. It turns out that for a lot of our designs, we actually validate them as they're coming off the line. So it's almost like we are playing a bigger and bigger role. And with the combination of the AI-based data processing tools, eventually I think, you'll have designers and then you'll have the factory pump it out. And then by the time the build is done, all that feedback will go back to the designers for the next build. I'm excited about that because you cut out all the send the prototypes back, probe it. No one likes doing that.
Yeah, it's way more fun now. When you get that result instantly, you get the instant gratification of, oh, this passed, I got a green light. And that used to be something you'd get prototypes or you get a small batch build in and you just get the product. You don't know anything about it. It's just, here, we did that, we made this. Let us know. And that's just a big drag to have to go to work through that. But when you get the instant gratification of results, photos, imaging, that really makes testing a lot more fun.
Yeah. What are you excited about, Cole?
Okay. Basically, I guess I'm excited about with the current wave of developer tools and no code, low code sort of tools, I guess, and also AI like ChatGPT and GitHub Copilot and Cursor. It has enabled a lot of hardware companies that have very small software teams to be able to have pretty solid infrastructure. Yes, I did say earlier that a lot of companies still have very legacy systems, and but there's obviously a whole new wave of hardware startups where the electrical engineers and the mechanical engineers are actually building pretty interesting systems thanks to these new tools, which allows them to be more competitive and can probably help equal the playing fields versus the FANG players.
All right. Well, thank you guys. I appreciate your time today, and thanks everybody for listening to the Future of Functional Test.